Hey everyone, Sam here. Let's do another daily Leetcode question. It looks like we're doing a palindrome this time, so let's start the timer and see what we got. Follow along as I do this, and I'll basically be talking about how I'd approach this problem in a tech interview. This looks to be, since it's an easy question, probably a phone screen candidate type question. I'll be doing it in Python. Let's see what we get. So given an array of strings, words, return the first palindromic string in the array. If there's no such string, return an empty string. Okay. So iterating through strings, and the string is palindromic if it reads forward and backwards. All right, I think this sounds pretty straightforward. So we're given a list of words, and we're just going to iterate through them until we find the first one that's a palindrome. And it says the first string. So just kind of thinking about the big O right here. In the worst case, if there's n strings, k chars in a string, no matter what, you're going to have to look at every single word because it might be that the last word is the only one with a palindrome. So we're doing at least O of n. And then to check if a word is palindrome, in the worst case when it is, you have to check at least all the characters in the word, -1 maybe. So you're going to be doing in the worst case O of nk. In the best case, that's there for time. I don't think we can ever do better than O of nk time complexity because you have to check every single character in Word. Space-wise, I think we should be able to not create any new arrays or anything like that, space complexity, so ideally. This is kind of what we're going to aim for. Yeah, let's just talk about the approaches at this point. This one's pretty straightforward, and let's have a look at the examples. So here, words is ABC, car, ADA, that'll be our first palindrome. And the race car and cool. And race car is also palindromic. Oh, that's kind of cool. However, it's not the first one. So we don't even need to worry about checking anymore after we get to the first one. If none of them are palindrome, in this one race car is. So it's the second one. And we're returning that string itself. Okay, that's kind of cool. And then finally, if there is no palindromes, we return an empty string. So, okay. I'm going to talk about kind of like my approach, how I'd like to do this. It is kind of not really brute force. It depends on how you want to calculate the palindrome of a string. But what we're just going to do is iterate over words, check each word is palindrome, return first success. Basically, that's the whole logic. And I don't think there's anything more clever to do than that. If the strings were sorted, we might be able to make some arguments for something else. That's a question to ask the interviewer. Is there any extra information being provided? Here we know the length of the words will be at least one word. As a quick check, if there was no words, the answer is still empty, I suppose. The length of the string fits in memory, no more than 100 characters, and only lowercase English letters. Not that it technically matters for a palindrome. Note also for an odd-numbered string, the center character doesn't really matter because it'll be a palindrome either way. But if it's even, then you have to check every one. So let's do this for word in words, I think is how we'd start with this. We're going to get a string, check palindrome word, and if that's true, let's actually make this snake case, return the word. Otherwise, we return an empty string. That's the general logic. We need to create this function, check palindrome of a word. And the way we like to do that is we're going to iterate over chars up to half the length, compare to the opposite side. So let me just explain what I'm thinking about there. If you haven't seen something like this before, let's say we have our palindrome ABCD CBA, and this is going to be 3, 6, 7 length. And we're going to compare this letter A to this letter. And then we're going to compare the second one to this one. And we're going to keep doing that. And hopefully everyone can see this. Good. All right. To this one. And then we don't actually have to check the center one because there's nothing to compare it to. It's going to be true either way. But it looks nice. And the way we can do that is by iterating. So for, let's say, I in range, the length of the word divided by 2, and we want to truncate, round down, because we don't actually care about the center one. So this double slash is a down, truncate down. So for example, 3 divided by 2 is 1.5, depending on which Python version you use, but 3 divided by 2 truncates down to 1. So that's kind of nice in this case. So we're going to compare if the word at I is equal to the word at, technically you could do negative I, that's one way you could do that. And if it's ever not, we return false. Otherwise we return true at the end. That's kind of one way we can do that. This is kind of a nice thing where Python handles this for you, but let's pretend we're not allowed to use that. I think you just take the length of the word minus 1, because you don't want to take the full length. If the array is 7, this will be the 6th index. 0, 0, 1, 2, 3, 4, 5, 6, see? So 7 minus 1 is 6, and then minus the I, and that'll give you the same thing as doing negative I here. This is just kind of a nice shortcut for that. And we're just comparing, and if the characters are never the same, if the characters are never the same, if they ever are different, then you know this word is in a palindrome. You can return false, otherwise return true. And we're just returning the word as is, and I think that's all we have to do. And this operation right here is O of k, and this operation is O of n. And so we're doing O of n and O of k here, and that gives us our total of O of nk like we thought about before. And we're not storing anything, we're just iterating over the pre-existing inputs. So we are O of nk time, O of 1 space. I feel pretty good about that. Let's remove some of this extra stuff and make it a little easier to read. And in fact, we could put this outside. That might speed things up somewhere else, but all right, 6 minutes, 40 seconds, seems fine. I'm trying to think of any edge cases. What happens if words was empty, for example? It would just return the empty string because it would never even start the iteration. What if there was no characters inside of a word? Then it would just return true because an empty string is technically a palindrome, I suppose. That's a question for the interviewer. We don't have to worry about that here. All right, let's try testing this on the test cases. Hoping this will work. Yeah, got accepted by the test cases. Let's submit it and see what we get. Submitting, and it's passed. Awesome. Super slow. All right. Why is that? I think, let's think about this. We're right around the 70, 80. I think it's probably because of this check palindrome function being right here in the middle, perhaps. There's probably some other ways you can check whether a word is a palindrome that takes advantages of the C backend. Step 1, let's just pull this out, and that way we don't have to reinitialize it every single time. And this will have to be self, I think, self in Word now. And now we can just call this separately anytime we need to do that. So I think that alone should give us a slightly better speed up just because we're not reinitting a function every call. Passes the test cases. Let's submit it and see how it does. A little bit faster, but not much better. Okay, this is where we start to drift away from what the goal of a tech interview is and the goal of optimizing for speed. So let's think about this. Am I missing any sort of optimization that is not a C backend thing? Let me know in the comments if you see something here. I can't think of anything just yet. All right, but the shortcut that I was thinking about, and this one is where you don't even use check palindrome anymore. You just you just check if the word is equal to itself backwards. If word equals our first word, like that, and this is now O of k space used. We're just checking if the reverse of the string is the same as the word, and that's what defines a palindrome. And this may be a lot faster. Actually, I think the other way you can do that is just -1, and that I think doesn't create new memory. I'm not entirely sure about that, but let's test this and see how that looks. Okay, and let's submit that. Okay, and now we're inside the bell curve. So this is something I'm not a huge fan of. So the reason I didn't go straight for this is because the goal of an interview is to kind of explain the thought process between iterating over the characters inside of a string for a palindrome. I would be happy if someone started with this and then asked them, hey, do you mind doing it the other way? But if you can explain yourself clearly, it's totally fine. So the idea here is a palindrome is the same forward and backwards. So if you can iterate through the word forward, compare it to backward, this is creating a new copy in a sense. I think it's a slice in Python, which may not use space. I'll try to add a note somewhere once I figure this out. However, a lot of a lot of implementations of something like this generally does create a whole new copy of that word. So we've just gone from a O1 space solution to a OK space solution, which is fine as long as you explain why you're choosing that or not. In this case, it makes sense because it speeds this up greatly. There's some arguments for some other ways we could do this, like with the reversed versus that. I think these are all just minor optimizations inside of the backend for running this code in the Leetcode servers. I wouldn't worry about it too much. Trying to think of any other optimizations that are interesting. We're all within 10 milliseconds, so I wouldn't spend too much time trying to optimize this, but let's have a look at some of these solutions and see what we get. Yeah, they just do this. It's exactly the same, just with less letters. Okay, so I wouldn't worry about it too much. You can see the whole code right here. All right, this was fun, and I hope it was fun for you all as well. Let me know in the comments if you were able to solve this problem and if you tried this a different way or used a different language. See you all next time. Cheers.